Then we move to a bubble sort. A bubble sort is quite simple. Each time you compare two. If it is smaller, bubble it up, move it the up, change the position. Always put it in the proper position. Okay? So it is something like bubbles in the water. The bubbles always come up to the top layer of the water. Then that is what you aim to find in some orders. Okay? So the bubble sort uses the same strategy. First is find the next item, then put it in a proper place. But it uses a different schematic to find the next item. So it always starting with the last list element, because you always bubble from the bottom to the top. You search from the last. You compare pairs of the elements, okay? Each time you compare, you always do the comparison. And swap whenever the bottom element of the pair is smaller than the one above it. Okay? So let's show a simple example. So firstly, we come from here, right? We compare this Bob and Jim. If we want to in an ascending order, okay, the alphabet ascending order, then you find that B is smaller than J, right? So you swap them. So Bob is popped up. Then you compare Bob with the upper one more time. And Bob is small, is still smaller than it. Bubble Bob up again, bubble up. And compare with this one. And this time, Bob is larger than AI. So it is changed to AI in the bubble. Bubble is changed to AI. You always bubble the smallest one from the bottom to the up. And then you compare AI with this next to it. AI is smaller, so bubble up AI. So this one has been sorted the first position. Okay? This is the first iteration. How we find the first number and how we pop it to the top of the layer, okay? So it's similar way. Then remaining these operations, okay? Do this after class. You can try by yourself. Do this one more time from here, okay? And then finally you find the second smallest number, and third smallest number, fourth smallest number, and all has been sorted. This is a bubble sort. So we can find in bubble sort you do a lot of comparisons. Bubble sort is very thorough. So can you find a way to make it a little bit faster? So that's a lot of the fantastic computer scientists do. They use their very smart brain to always want to find a faster algorithm. So one question for you to consider after class is that under what situation bubble sort is fast? Okay, which situation it is suitable? So similar, we can write a bubble sort pseudocode. Okay, set some variable as marks and do a loop in which condition, and in each loop we do the swap. We do the bubble and do the swap. Okay, similar way in the bubble sort. And how to do the bubble up? We need additional algorithm for subtask. So it's just a swap, right? But you need to define some variables similar like for the earlier one. So we have talked about selection sort and bubble sort. Is there any faster approach? We are going to talk about insertion sort. Insertion sort is very frequently seen. I don't know whether you play poker or not. If you play pokers, each time you get a new card and you need to put it in a proper position in the cards in your hands. You search from the left to the right, and you insert it in a proper position. And then you get a new card and insert in the proper position in your hand. So the cards in your hands are always sorted. And each time you find a new card and insert it in a proper position. That is insertion sort, the main concept of this insertion sort. Okay, so the precondition is that if you have only one item in the array, so it is already sorted, right? So this is the start condition. Then you get a new card, you have two items. So you can compare and swap if necessary. So it is sorted, these two. Then take the third, put it in the right position. Then do it until all item has been processed. So the item being added to the sorted position can be bubbled up as in the bubble sort. It's similar, right? So considering I just only have one card, then get a new card here. So you can do the bubble up. Then these two is sorted. Then get a new again and then do the bubble. Right? So insertion can be combined with the bubble sort to increase it. So similar, we have a pseudocode. We will not go further detail about this pseudocode. Okay, so after we talk about three sorting algorithms, one last sorting algorithm I'd like to mention is the quicksort. Quicksort use the concept about divide and conquer. So as we mentioned about the subprogram. So when we write the pseudocode, we can give a section of code a name and use the name as a statement in another part of the program. Okay, we do it a lot in this like bubble sort. We use the bubble up as a name, and you use a subprogram. This approach has been used one by one a lot in our examples, right? Okay, so this is also frequently used in the programming, computer programming. So each time when the name is encountered, the processing in that part will be executed. Okay. Okay. So we call this calling. Okay, calling functions or calling unit. So we need some parameters and arguments. You need to transfer some parameter when you're calling some subprograms, or you need to subprograms to return some parameters for you after it is executed. So this is an example shows how these two subprograms, how the subprograms can be called in a main program. Okay. In a main program, if this subprogram come up, then it goes to the subprogram, and after finishing it, it goes back here. Okay. So similar, if this subprogram can be in a sentence or a formula, then similar way to call these subfunctions. Okay. So after this, we let's move back to the quicksort. Okay. It uses a concept about this recursion. So recursion is that a problem can be divided as the same problem, but smaller. And you do this subprogram. It is the subprogram is to call itself because the problem is same, right? So let's see. This is a concept about recursion to calculate one times, two times, three times until n. Each time it equals itself times the rest, and then this one can call this one more time, call itself. So this is a recursion concept. So similarly in the quicksort, we use this recursion concept. So if if it is included from A to Z characters, we can divide it, sort them between A to L, and sort between this M to Z, and divide it half-half, half-half, and divide it one more time until it has only one element left. It is sorted. Okay, divide the problems. So we first define a smaller case, and we need to define a base case for this quicksort algorithm. Okay, we also use the variable first and last in this quicksort algorithm. So basically, it is just a very simple idea due to this recursion. Okay, so here we also have the pseudocode, but we not go detail, and we have an example. Okay, you can check this example after class. We use some flags to mark some remarkable values, and you do it one step, do the iterations. In the computer, it's always iterations. Okay, thinking in the computer way. Okay, so I showed an example here, exactly showed from the initialization to how it ends. So a very detailed example. Okay, check this after class. Okay, so recall some important stories for you to remember. Firstly is information hiding. Okay, the practice of hiding the details of a model with the goal of controlling access to it. You don't need all the details, hiding some information. And do the concept of abstraction. Okay, some complex systems, you don't need to include the details. You just abstract it in a high level. Okay. So information hiding and abstraction are two sides of the same coin, trying to figure out the concepts of them. So in the abstraction, when you design your algorithms, you use the concept of abstraction. We can consider it from the data abstraction, the procedure abstraction, and the control abstraction. Abstraction is like you don't need to know how the bones, how the blood of a dog. You just know how it runs, how it moves. You just get to know the up-level things, okay? So you consider from the data viewpoint, you consider from the procedure viewpoint, and you consider from the control viewpoint to do the abstraction. And this figure shows the abstraction, okay? This is the abstraction. You don't need the details. For the computer students, they need to know how these bones are constructed. But for all of you, other measures, you just get to know the abstraction, the high-level concepts.